Page number 7.79. The question is how twisted they are asking. They are given E is equal to E naught sin omega t. The moment they give you E is equal to E naught sin omega t, you know when sin 0 is 0, voltage will be 0. So when normally I'll do current only like this, no? Yes. Here I can't do current like that because EMF only is 0. So you should draw like this with big amplitude, and that is my graph, given graph. Yes. This is a question is given that is an LCR circuit because you see that across the series combination of L, C and R. Use the phasor diagram to obtain an expression for impedance and phase angle between the applied voltage and the resultant current in the circuit. That is the derivation which I have already taught you. Yes. But they give, to confuse you, they have given, hence show that the current leads, which is nothing but H. Current is either leading or current is either lagging. It is the same derivation only. But when omega is less than 1 by root of LC, so the conditions are current leads or lags when omega is less than 1 by root of LC, omega is equal to 1 by root of LC, and omega is greater than 1 by root of LC. Three conditions they ask me to check. I'll tell you what. See, normally you at this is the condition for resonance. So you, as soon as you see, you know this is a condition for resonance. When XL will be equal to XC or L omega is equal to 1 by C omega, omega square is 1 by root of LC. Omega itself is 1 by root of LC. This you already know. Yes. But look at this. In this, if XL is greater than XC, this condition will occur. This condition will occur when XL is greater than XC. Then L omega will be greater than 1 by C omega. So omega will be greater than 1 by omega square will be greater than LC, and omega will be greater than 1 by root of LC. This is the condition with which I did all the derivations in my, where I consider always capacitance is less powerful and inductance is more powerful, so that you know in my this is resistor and this is XL and this is XR and XC, and I'll get the resultant to be XL minus XC, and this will be the resultant and all that, and this will be phi naught. You know all this, no? So that is the condition on which I have done it. Yes. This one will be supposing capacitance is more powerful. So then XL will be lesser than XC. So L omega will be lesser than 1 by C omega. Omega square is lesser than 1 by LC. Omega is lesser than 1 by root of LC. Therefore, you clearly understand that this condition stands for purely this capacitance is more dominating. Yes. This is capacitance is more dominating. This is inductance is more dominating. So this one I have already mentioned in my video. First video you have recordings. If they ask you like this, what will you do? You will say that ER is like this, and EL is kutti, and EC has to be greater, so that you will get a resultant like this, which is EC minus EL, and therefore you will get a resultant EMF which is root of EC minus EL the whole square plus R square. EC minus EL the whole square minus R square, where this is minus phi naught because it's in this direction, negative direction. Okay, so then this is how you write it, and you already know this can also be drawn as with resistance and inductive reactance and a capacitive reactance, where it will be XC minus XL, and the resultant, this will make an angle phi naught, and you know tan phi naught itself is opposite, which is XC minus XL by R, and you can also write cos phi naught because this will be impedance, which is root of XC minus XL the whole square plus R square. So you can also write it as R by Z. This cos phi naught is very, very important. Okay, power factor. Sometimes they give you graph. From that you can also write power factor. Yes. Although power factor's definition is actual power by apparent power, there's also R by Z. So keep that in mind. Yes. So this is something, when they ask you questions like this, don't panic. Okay, then they are referring to this one, and I'll continue like this. That's all. But when you do the phasor diagram, they've asked you for a phasor diagram. In the first one that I taught you, you know how to do the phasor diagram. You know that your ER will be here, your L will be here, your EC will be here, and the resultant will be like this, which is E is equal to root of EL minus EC. EL minus EC the whole square plus ER square. ER square, not R. It is regarding to the resultant EMF.
Yes.
Making an angle, you know that the current will always be in phase with the resistor. And this is the resultant EMF. The resultant EMF will is supposed to make an angle with the x-axis. That's the whole angle.
Yes.
Okay, supposing this is phi naught, supposing this is going to make an angle omega t. The whole angle the resultant makes with the x-axis will be omega t plus phi naught. So E is equal to E naught sin omega t plus phi naught. Considering that inductance is more powerful, their current will be I is equal to I naught sin omega t, where it shows that EMF is leading.
Yes.
This is how you do the phasor diagram. They asked for phasor diagram. Now for capacitance, how do you do the phasor diagram? Is this is your ER, this is your EC, and this is your EL, and you know EC is more powerful, so you get EC minus EL, and there will be a resultant like this where E will be root of EC minus EL the whole square plus ER square, and you know this is your phi naught, the resultant making with the ER, but you know that current has to be in phase with the resistor, and the current should make an angle omega t with the x-axis. See, in this, if it is omega t plus phi naught, if capacitance is more powerful, the entire final answer itself, you know, it should be E naught sin omega t minus phi naught. Okay, so such a way you have to construct. You put x-axis in this in here. In this case, you put it here, so it became omega t plus phi naught. Here it should be omega t minus phi naught. So where should I place my omega t? If so, then where should I place my x-axis? Okay, the angle that this resultant makes with the x-axis should be some big angle minus phi naught. So some big angle minus phi naught. Okay. So in this, I'm going to draw the x-axis like this. Okay, I'm going to draw the x-axis like this. You know that the I naught is always going to make an angle omega t with the x-axis, and so then the resultant EMF making with the x-axis will obviously be omega t minus phi naught, and this is the phasor diagram. Normally this x-axis has to be drawn like this, but you can also do like this. There is no harm in doing it. Okay, that's just a question of drawing like this. Okay, so you get this, you get the phasor diagram with which you have mentioned this, and you know I has to be I naught sin omega t. So this is what, by using phasor diagram, how do you justify for XL is for omega is lesser than 1 by root of LC and omega is greater than 1 by root of LC. So next point that I'm going to teach you is about a graph, a very very important graph. So you know impedance is equal to root of XL minus XC the whole square plus R square, which itself is L omega minus 1 by C omega the whole square plus R square is Z. Consider this omega high frequency. Consider that omega is very very high. At high frequency, the inductive reactance will dominate, or inductance is dominating. But at high frequency, capacitance XC is becoming negligible. So capacitance is becoming negligible. Capacitance itself is very approaching zero, negligible. Okay, so then it's purely it's not purely, inductance is dominating. So then for a high omega, inductance is dominating. Okay, for a low omega, capacitance will dominate. If you know this is going to dominate, if you know this, then if they'll ask you very important question, there's no paper without this question, impedance versus omega. Okay, so you know high omega, inductance is going to dominate. In inductance, you know XL is directly proportional to omega. Whereas at for a low angular velocity, capacitance is going to XC is equal to inversely proportional to omega. XC is equal to 1 by C omega, correct? So you know, therefore at lower frequency, which is this part, it should behave like capacitor, and capacitor is inversely proportional. And then at a higher frequency, it's going to be directly proportional. The graph has to be drawn like this. This is how you should draw the graph. The point where the capacitance and the inductance is meeting, you can call that as Z is equal to R. That is occurring at resonance. So this graph is so important, and this gives you an idea as to how the graph is drawn and everything. Are you clear? Such a beautiful input, no? So that's number one. Next one, I am going to do the 16th question in SL Aurora. That is in 7.80 page number. I'll read the question for you. A device X is connected in an AC to an AC source, some device. I don't know whether it's inductor, capacitor or resistor. But I am seeing this V is equal to V naught sine omega t is given. So all I know is when I draw a graph, I should start EMF from zero. No other go.
Yes, ma'am.
I can't fix a current and then do EMF.
Yes, ma'am. Yes, ma'am.
Okay, that is, you should be very clear with that. Even in my first derivations, I used to write E is equal to E naught sine omega t. But when I drew the graph, I was doing for I is equal to I naught sine omega t. So I would suggest you all to draw the correct diagram.
Yes, ma'am.
So for this assumption where you're dividing both sides by R.
Oh, R, yeah.
First case, and you get I is equal to I naught sine omega t. You should, so that's okay because in this both of them are in the same phase, so you could. But when it comes to inductor, how do you do it? You know that you start the derivation with E is equal to E naught sine omega t, and you divide both sides by an L. You divide both sides by an L. Because E is equal to minus L into di by dt. So this become di by dt in itself.
Yes, ma'am.
So then this is how I start deriving.
Yes, ma'am.
So ideally I should not draw I is equal to I naught sine omega t in that graph, though I did it there.
Yes, ma'am.
If I start with I can do like that.
Yes,
that has to be corrected. And I hope you all have the clarity to correct it now.
Yes,
so then this is about EMF only must be drawn from here, and based on that I know in the inductance circuit and the current will be lagging behind. I'll eventually get I is equal to I naught sine omega t minus pi by 2. So then when I draw the current, I should draw it like this.
Yes.
Okay, so please change that around if you want a center, because what the derivation I'm writing and the graph that I'm doing are two different things.
Yeah.
Okay, so make sure that your only this phasor diagram is all fine. Only this graph I have actually done the converse of it.
Yes,
so don't want just exactly follow. I hope you are all clear. I hope you understood that the first video needs a bit of correction, which is the graph.
Yes.
So then in the case of because we are starting with E is equal to E naught sine omega t. Similarly, take E is equal to E naught sine omega t for a capacitance. You'll multiply both sides with C and you'll call this as Q, and you know you will differentiate it.
Yes,
so here again you should have drawn only EMF first like this.
Yes,
and then based on that you could have drawn your current. Here you know current will be ahead. So you could have drawn your current like this by pi by 2. That is different.
Yes,
so then make sure that the graph in the first video is corrected. I'm making it very clear now. Okay, that was some random graph where I fixed I and I wrote E.
Yes, ma'am.
But let's fix E and then because derivation we're fixing E and then deriving I, so it makes sense for us to do that. But because if you're getting a centum, then it's a problem. So then first you see this and first draw the EMF. EMF's amplitude is much greater. And so then you draw it and write it as V naught or E naught, whatever. But now what are they giving? They're giving a circuit. They're giving okay, this is what it is. But the question is different. They have given a graph here in which they have given one dotted line which is like this, which is going like this. Okay. Then they have given a thick line which is going like this. Okay, it's just going like this and like this and like this and like this. A thick line which is going like this. Okay, and next they have also given a big line like this, where this is going like this, like this, like this, like this, like this, like this. Okay, like this. What is the meaning of this? They have named it as, they call this this as A.
Yes, ma'am.
They are calling the thick black line as B and the dotted line as C. They are asking me to identify this. I know that since this is voltage,
yes, ma'am,
and it has to start from 0, I know this one, that is the B, which starts from 0, is actually my E naught, EMF.
Yes, ma'am.
Yes or no? Because I know that they have given one is power.
Yes, ma'am.
One is EMF. Another is they have given one other is current. So when one is current, obviously you know that either the EMF or current should have bigger amplitude. But in this question, they have mentioned the EMF and the current to be having the same amplitude, which itself is wrong.
Yes, ma'am.
Which cannot be the case. But however, if they give you like this, you don't know which one is current and which one is EMF. Look at this. This starts with B is equal to V naught sine omega t. Therefore, the EMF will start from 0. Therefore, the B is the EMF.
Okay.
A will obviously be power. Because power is the multiplication of voltage and current. So then therefore it has to have maximum only. Correct?
Yes, ma'am.
So the biggest graph, highest amplitude is always power. The other thing that is therefore dotted graph. That is C will become your current.
Yes,
So
ma'am.
you're clear. Like this, first you should identify.
Yes, ma'am.
In this, if you see, the current is ahead.
Yes, ma'am. Current is ahead.
When capacitor only current will be
Current
ahead.
will be
It's and that too just by 90 degree.
90 degrees.
The phase difference. So
Phase
then, therefore, it is a purely capacitive circuit. They will ask you to identify the device X.
Device
It's
X.
purely capacitive. That's
Yes,
the
ma'am.
first question.
Yes,
So,
ma'am.
so much detail. If you don't notice that V is equal to V naught
V
sin
naught sin
omega
omega
t
t.
and assume that it's going to be starting with
I-
0,
yeah.
you cannot identify which is
Yes,
E and
ma'am.
which is I and
I
can
know.
get lost in the
Yes,
sum.
ma'am.
So next is, which of the curves ABC represent voltage, current and power? We have already
Yes,
said that,
ma'am.
and justify your answer.
Yes,
Because power is a product of voltage and
into current.
and this V is equal to V naught sin
V naught
omega
sin
t. You
omega
know
t.
that B is only EMF,
EMF.
and such clarity we have.
Yes, ma'am.
So then, how does its impedance vary with frequency? I just taught you that.
Yeah.
First of all, this is a pure. No, I didn't teach you. Next part of the question, second part of the question, how does impedance vary with frequency? They shouldn't call it impedance.
Yes.
Why? Because it's purely
Purely
capacitive.
capacitive.
They should have called it as inductive, it's a capacitive reactance. They should have called it capacitive reactance with omega. Xc is equal to 1 by C omega. Xc is inversely proportional to omega. Xc versus omega should be inversely proportional. That's all.
Yes.
It is improper to call it as impedance.
Impedance.
You call it as impedance only when it's LCR or LR or CR.
Yes, ma'am.
Okay, so that completes it. The third one, how does it's
Obtain an
show
expression.
graphically also we have
Yes,
shown it.
ma'am.
So the fourth one is D is obtain an expression for the current in the circuit and phase relation with an AC voltage. That's the whole derivation
Yes,
of exclusive capacitor with an AC source.
source.
You know what is the
Yes,
moral of
ma'am.
story? This Q is proportional to V. Q is equal to C into V. You start with E is equal to E naught sin omega t. Multiply both sides. This will become Q is equal to C into E naught into sin omega t. Where you differentiate this, you get dq by dt, which is sin omega t will become anyway cos omega t into omega. C omega E naught into cos omega t, which can be written as 1 by C omega. Why do we write like this? Because I should be E by R, and this is behaving like a resistance. It's called capacitive reactance XC.
Capacitive.
So this itself is I, which is I naught sin omega t, not cos omega t, and in order to convert into sin, you write I is equal to I naught sin 90 plus omega t,
Plus omega.
or omega t plus 90
90.
because it's capacitive. The current
Capacitive.
has to be ahead.
Ahead, yeah.
Inductor starts with the letter I, where
I,
current will be
current
lagging.
lagging.
So then with that you write this derivation. That's all
Yes,
they're
ma'am.
asking. Obtain expression for current in the circuit, and it's we
And
got a
that's
current
what
in
we
circuit, and the phase relation with AC
AC
voltage is pi by 2.
5 by 2, yeah.
And you can draw the phasor diagram
Yes,
and stuff. You know how you draw it. You know that phasor diagram is like this. This is I naught, and this will be current is okay. Current is always drawn like this.
Yeah.
EMF is lagging behind. So we'll draw here. So you'll write resistance here and EL here, and we'll do the EC here. I'm sorry, and it will be E will be root of EC square plus ER square, and this is your phi naught, and you'll write tan phi naught,
Tan phi
and
naught.
you can also write it with R and XC.
XC.
And this will be again, actually this is minus phi naught in. That's
Yes.
why you get EMF to be E naught sin
E naught
omega
sin
t
omega t
minus pi by 2. But I always have the habit of writing this way.
Yes, ma'am.
But it's okay, that doesn't matter.
Yes,
Okay, so then that's about this, and let's go to next question.
Yes, ma'am.
Next question, it is so this question is in page number 7.80. Okay, so which is very difficult, where the 17th question B part, draw a graph to show that phase relationship you have to show relationship between an instantaneous flux and an instantaneous induced EMF. Instantaneous flux
Yes.
and an instantaneous induced EMF. Okay, so what we do is, you know the formula for flux is B ds cos theta, which will become cos omega t, and you know E is equal to d phi by dt. On differentiating this, you get minus B ds sin omega t into omega. So this has become a sine graph, this is a cos graph. So in simple terms, you know that if you're going to do a flux, the first graph, which is the flux versus time graph, flux versus time graph, you know, when cos 0 is there,
Yes, ma'am.
this is B and area is A. Let's not keep it area as ds, we can consider it as A. So B into A. Supposing there are n number of turns, it's simply NBA. So you can consider this to be NBA, and it's a positive value. And then at cos 90 will become 0. In this, if you see cos 90 at 90 degree, which will be, this is 0 to t means, and the half of it will be t by 2, so this will be t by 4, and this will be 3t by 4, and so at 90 degree this is going to become 0, and at t by 2 it's going to become maximum. The graph is going to go like this, and this is the graph for flux.
Yes.
I have drawn this graph. Now let's do the EMF graph. You're going to do a separate graph for EMF, or in the same graph also you can do. If you're going to do this, you know it's a sine graph. And sine 0 is 0. So you should start with 0. And sine 90 is 1, will get minus B omega A. So then shouldn't it be going down in the first place?
Yes, ma'am.
In Aurora, they have given wrong answer because E is equal to minus. Okay, first of all, E is equal to minus d phi by dt. No, then therefore you have to differentiate this, which is NBA cos omega t. When you differentiate, you get minus, and minus of minus will become plus only.
Correct.
So it's correct only in Aurora. So you, when you draw, it will be NBA. At when cos 0. So it will start with an plus NBA, and then at t by 2 it will become 0, and then when it is maximum, this will become what is it? This is pi, and cos pi means minus 1. But whereas here it's a NBA sin omega t into omega also, and a sin pi will be 0. So then what am I doing? You know that this is 90, and this is sine graph. We should also start with 0, and sin 90 is this value is NB omega into A.
Yes, ma'am.
Correct? And then it has to come like this and go like this. Compare this and this. Can you see it's lagging behind? Which is lagging behind? The EMF is lagging behind the flux by a phase of 90 degree. So that conclusion is such a beautiful thing. I hope you understood.
Yes.
So look at Aurora for the solution also. The next thing that I want to teach you, another part of the same question, where the current produced by an AC generator, that is sum number D in the same
C.
Sum number 17th C. The current produced by AC generator, can it be measured by a galvanometer?
Yes.
No, we cannot measure it using a galvanometer, because you know the average current over an entire cycle is 0. So then you know that the current produced by an AC generator cannot be measured with a moving coil conveyor, because the average current of an AC, average value of AC, which is actually average current over an AC, is also equal to 0. So then this is very important. Average current over an AC is always equal to 0. And they'll ask you for this proof. So then this proof they'll ask, the average value over an entire cycle of an AC. Entire cycle means full cycle. 0 to capital T or 0 to 2 pi is always 0. So they say average value, but we can to whatever value that is, it's going to be 0. So to prove this, you have to take Q is equal to I naught sin omega. So Q is equal to Q naught sin omega. No, you should take I is equal to Q by T. I is equal to Q by T. So Q is equal to I into T. Write it as dQ and dt. And instead of I, you write I naught sin omega T into dt. And now you can integrate both sides. You get Q is equal to I naught cos omega T with a negative sign. Integrated from 0 to entire cycle is capital T. You can take the negative sign out.
Yes, ma'am.
And you also know you'll get a by omega. Because when you integrate sin omega T, you have to have a by omega. Take it out. And so thus you have a cos omega T, integrate from 0 to capital T, upper limit minus lower limit, cos of omega into small t. Instead of small t, you can write capital T. Instead of omega, you can write 2 pi by capital T. Capital T get cancelled. Minus cos 0. For time is 0, cos 0 you'll get. This is minus 1. Minus 1, you're getting minus 2. You are not supposed to get minus 2.
Yes.
You're not supposed to get. It has to get cancelled. Correct? So what is the mistake? You have to, we have to figure out I naught by. This omega also can be written as 2 pi by capital T. That's okay. But this cos omega T, okay, let me do it again. cos into 2 pi by capital T into capital T and T get cancelled. Cos 2 pi is 0 only.
Zero. Yeah.
Why did we put it as minus 1?
Minus 1, yeah.
Cos 2 pi is here, not cos pi. So it's 0.
Yeah.
So this
2
is
pi
also 1.
1.
Minus lower limit is also 1
1,
because
so it
cos 2 pi
becomes
minus cos 0. This is also 1. 1 minus 1 is 0. Therefore, the charge itself is becoming 0. Very, very important derivation.
Yes, ma'am.
I made a mess, I'm sorry, but you please understand that cos 2 pi is not 0, it's 1. So 1 minus 1. No, cos 2 pi is not minus 1,
Minus
it's 1.
1, just 1.
Because the other derivation will get minus 1, minus 1.
minus 1.
When we are doing, I think, I average.
Yes, ma'am.
There's another derivation. Okay, so then this is 0 and that's about this. This question will also definitely come. Now I'll do some MCQs in this. Okay, I'll do some MCQs. Multiple choice question. First question in page number 7.83.
Yes.
The peak value of AC source. Peak value of AC source is always I naught, right?
I naught.
So it's I naught or E naught,
E naught,
depending
yeah.
on current or EMF. The value of the voltage supplied to the current, option A. The value of voltage supplied to the circuit. No, the value of voltage supplied to the current is always ERMS. The supplied voltage is treated as ERMS. B is RMS value of an AC source.
E naught value.
This is not, the peak value is not called RMS value,
RMS
definitely,
value, yeah.
correct? And then C is root 2 times the RMS value. You know, IRMS is equal to I naught by root 2. I naught is therefore root 2 times IRMS. Therefore, I would mark C to be the right option.
Yeah.
There's one more D. I'm not even bothered about that. Let's go to next question. The figure shows the variation of current with respect to time in 4 devices. They've given one device, which is P device, in which current versus time is going like this.
Yes, ma'am.
And then they have given another in which it's going like that. God knows what is this, okay?
Yes.
And there is another one where it is again like this. It's again like this only, okay? And that they are saying is S, and let's figure this out. And there's one more like this, which they are calling it as R. They're calling this as Q. I don't know what it is. Let me try to understand. Figure shows the variation of current with respect to time. All of these
Yes,
are varying
ma'am.
with respect to time. And PQRS are the 4 devices. The device in which is an alternating current flows. The device in which alternating current will flow. 1 second, hold on. This is somewhere they've given P, Q, RS or some instruments through which one. Actually, the question is wrong. Okay, I'll tell you what. In this Q, it has got to be a straight line,
Yes,
which shows that this will be a DC.
DC.
Okay, because current is a constant. Current is increasing with time, so R is also not possible.
Not possible.
Okay, because it has to be sinusoidal.
Yes,
I think in this P, it should have been like this,
Yeah.
where it's a rectified AC.
Rectified.
It's a rectified
Yes.
AC. Yeah, it is fluctuating from here to there, but not in negative direction. So only S will be the right answer. So
Yeah.
because it is positive as well as negative and is sinusoidal. So the question itself is wrong, is what I presume. So this question is about the third MCQ. Okay, so where V is equal to V naught sin omega t. Where they are saying V becomes V naught.
V naught.
When will V become V naught? When omega t is 90 degree.
Yeah.
But when will omega t be 90 degree? Instead of omega, put 2 pi by capital T. Instead of small t, you put capital T by 2. So capital T by 4. That's when 2 and 4 will get cancelled. T and T get cancelled. You get answer as pi by 2. So therefore this occurs at a time T by 4. Now obviously T is lying between 0 and T by 2, because this T is nothing but T by 4. It makes sense.
Yes.
Then V is equal to 0.
0.
When sin omega t itself is 0, for which omega t has to be 0 or omega
Pi.
t has to be pi.
Pi.
Which means the timing is like pi means it's the time period is half t by 2.
Yeah.
So you know, and this is 2 pi also you can take.
Yes, ma'am.
So this is from t by 2, because you can't take this. You have to continue
yes,
with this. You should take t to be t by 2 to t. It is going to take a value which is 0.
0.
Let's draw this graph. So you know that V is equal to V naught. For this is for a time period t by 2. This is for a time period t. So this is V is equal to V naught. And this is becoming 0.
0.
So you are going to, they are asking you find ERMS or VRMS, which is root mean square value. This value is V naught square. This value is 0 square. By the time is not t, you should take it as this is one sector, this is another sector. So 1 plus 1, 2. So when you do that, it will become V naught by root 2. So ERMS is equal to V naught, E naught by root 2 should be the answer.
Yes.
So then therefore, I'll just therefore do another sum
Okay.
where I taught you in the intro video also. What if it's a pulsating graph of current
Yes.
like this?
Yes.
So then if it goes like this, they'll give you 0, 1, 2, 3.
Yes.
So in this I could divide it by 3
Three.
because even though time is 3, the mean is also
Mean is
3
also three.
when I take it by 3.
By 3.
So this is supposing 2 is the value, the minus 2 is the value. I'll write root of 2 square plus minus 2 square, which is also plus 2 square, plus 2 square by 3.
Yes.
So solve this and that will give me my IRMS value.
Yes.
But instantly this was still 1, 2 and
1, 2,
3.
3.
I thought the time is 3 and I thought I'm dividing by 3, but it's the number of sections is 3 and you should always divide it by the section.
Sections.
But it
Yes.
so happens in this it is 3.
Three.
But in the sum it was not 3 because it was still t by 2 and for t, and so then this section is divided into 2, and so that is what they are dividing by, and that is a surprise to me.
Okay.
Okay, so let's go to next question, which is the next MCQ is the fourth MCQ. In an AC circuit, the instantaneous values of the current and voltage are I is equal to 5 sin omega t and E is equal to 200 cos omega t plus pi by 3 respectively. The phase difference between the voltage and the current at any instant. Phase difference between the voltage and the current. Isn't it just you have to convert this into sine, so that to exactly spot the phase difference.
Yes.
Okay, so convert this into sine. You get 200 into sine 90 minus omega t plus pi by 3 with a bracket.
Yes.
So E is equal to 200 into sine of 90 minus omega t minus pi by 3, and pi by 2 and a pi by 3 has to be solved.
Yes.
So when you solve this is 6, this is 3 and this is 2, 3 pi minus 2 pi is pi by 6. So this will become pi by 6 minus omega t with a 200 and a sine. Correct? Now you know that when you switch this, you know, sine of minus theta, do you have, okay, I'm stuck with the sum, let me think about it and then do it. Okay, sine 90 minus omega t. See, I got it like this, where I am supposed to get sine omega t minus pi by 6, I am not getting it in the right form.
Yes.
So there is some mistake. What is the mistake? Go back. When you write cos theta, you can also write it as sine 90
90
plus.
plus.
So let us try with that.
Okay.
When you know pi by 2 plus pi by 3 is 6 is LCM, this is into 3 into 2, so it will be 5 pi by 6. So I can also write it as omega t plus pi by 5 pi by 6. Okay, so I'm going to write it as sine omega t plus 5 pi by 6. So I understand that it is 5 pi by 6 ahead by EMF is ahead by 5 pi by 6. So you should write it as minus or a plus and then infer. From this, you know, EMF is ahead, current is lagging, which means it's a inductance is dominating. It's not purely inductive circuit.
But it's
Dominated. Why? Because it's not 90.
90.
For me to say it's a purely
Purely
inductive. Its inductance is dominating in the circuit. So let's go to next question. Fifth question. The RMS value of the current is given by I is equal to I1 cos omega t plus I2 sin omega t. Okay, they have given by RMS value is given like this. Okay, they are asking me to find RMS value of the current is given by this. You know, is I don't know. I think they are asking for RMS value. I don't know. Then what is this? Let's see. Okay, let's you know, this can be written as I1 cos omega t I2. Can I convert this into? I'm just trying. Okay. Sin A cos B plus cos A sin B. Can I write this as a sin A and cos omega t plus cos A sin omega t? I'm just exploring. I still don't know. This is like sin A. Can we have it as R sin A and R cos A, where R into sin A plus omega t I'll get, and this is my maximum amplitude, and I get this omega t plus A. And what is A? You know, I1 is equal to R sin A. I2 is equal to R cos A. Let's add these two and square this and add.
Yes.
I1 square plus I2 square is equal to R square into plus into sin square A plus cos square is just 1. R is equal to root of I1 square plus I2 square. So the resultant itself is R, which is the peak current. I got a peak current to be I1 square plus I2 square, which corresponds to I is equal to I naught position. sine omega t plus a. So then therefore I know that this is I naught.
I naught.
I got I naught, and if you want IRMS is I naught by root 2. So can I write as root of I1 square plus I2 square by root 2, and thus I got this as answer, which is option number C. I1 square plus I2 square root of by root 2. Yeah, so then option number C is the answer.
Yes, ma'am.
Look at the way I'm trying to do. It's very, very difficult.
Yes, ma'am.
This is like R sin A and R cos A.
cos A.
And then that's how we do it. And let's go to next question. Is the sixth question, where an ideal inductor is connected to an AC source. So inductor
Yes, ma'am.
is connected to an AC
AC
source.
source.
You know pure inductor how it behaves.
Yes, ma'am.
You know the current will be lagging behind by pi by 2. So then the option you see lags the voltage by pi by 2. So D is the right answer.
Yes.
Let's go to seventh question. An alternating current of EMF 400 sin 100 pi t is applied to a circuit containing an inductance of root 2 pi by h. So then you have an inductance, and this is like E is equal to E naught sin omega t, where omega itself is 100 pi,
100 pi.
and you know E naught itself is 400.
Yes.
You know that L has been given. If an AC ammeter is connected to the circuit, it's reading the current reading, which means IRMS value.
IRMS.
Okay, IRMS value. You can find ERMS using E naught by root 2. E naught itself is 400 by root 2, and once you get then you can write ERMS by impedance.
Impedance,
But it's a
yes.
purely inductive circuit.
Yes, ma'am.
So you just have to divide it by XL.
XL.
So it's 400 by root 2
Root 2
into L omega.
L omega.
What is L omega? 400 by root 2 into what is L? Root 2 pi. That's all. Root 2 and root 2 is 2. This pi will go up.
Up.
So 400 pi by 2, it's 200 pi.
Pi.
So I got what? I got RMS itself. And then they want a decimal number 200 into 22 by 7 or 3.14, whichever you like. So let's multiply this. 4 2s are 8, 2 1s are 2, 3 2s are 6 with a double 0, 628. I'm getting some forgot to mention omega. Omega is equal to, can you see from this graph, omega is equal to 100, equation 100 pi.
100 pi.
So omega itself is 100 pi. You should also divide it by 100 pi. Correct? I forgot. It's 100 into another pi, and pi will get cancelled. Oh, the calculation is becoming easy. I forgot
Yes,
about it. So then you substitute L's value from here and omega's value. So this will become root 2. Pi and pi get cancelled. In fact, this and this will become 4, and 2 and 4 will become 2. So the answer is 2. But the answer says it's 2.2. Why would it be? Can we do the sum once again?
Yes.
You know that inductance L is equal to root 2 by pi Henry. Okay, so then now they have given, they want you to E is equal to 440. It's not 400. I took it as 400.
Okay.
Take the sum as 440, you'll get the answer. Are you
Yes,
clear?
ma'am.
I'm
Yes,
not
ma'am.
doing the sum,
Yes,
so you'll
ma'am.
understand how to do it. It's very, very important. It's a
Yes,
JE
ma'am.
question.
Okay.
Okay, this is your E naught.
E
Once
naught.
you know it E naught, you can find ERMS.
ERMS.
By doing ERMS equal to E naught by
E naught
root 2.
by root
So 440 by root 2 is my ERMS, and IRMS is equal to ERMS by XL, which is L omega. You know L, you know omega.
Omega.
Substitute and get the answer.
Yes, ma'am.
So let's go to eighth question. Eighth question. Which of the following graph represent the variation of current with frequency? So they'll always ask a current versus frequency graph, omega graph, or they might ask you even a normal frequency. This angular frequency, this is frequency.
Frequency.
They will ask any of this graph, but this seems to be current versus frequency only. Okay, but I would say, see, moment they say current versus frequency, my mind will go to this graph, okay, where this is peak value of current and this is omega naught. And this is omega naught plus delta omega, this is omega naught minus delta omega, and this is the value of I naught, and these two value corresponds to IRMS. This is the graph that will strike me.
Yes, ma'am.
And you know omega is nothing but 2 pi into frequency. So it doesn't matter, this will be F naught and this will be F naught minus delta F, and so it shouldn't make a difference.
Yes.
So I thought this could be the answer. However, if I see the graph, they have given options like this, where in A I get current versus frequency graph, which is like this. The option B is current versus frequency graph, which is like this. Then they given option D, which is current versus frequency and a current versus frequency like this. I'm lost because I thought I'll write this as the answer. I've always been assuming this could be the answer because we've already learned it in resonance.
Yes, ma'am.
But the option, none of the options show anything near what my assumption. None of it is near my assumption.
Yes,
So I'm stuck. So let's see the answer for this. The eighth question. The eighth question is so the option number C is the right answer. So current versus frequency, they have plotted this as the answer for it.
Yes,
So I
ma'am.
want to think. I want to think why the current versus frequency is like this, and
Yes.
what is it that I drew there then.
Yes, ma'am.
Correct, that
Yes,
was in
ma'am.
resonance.
Resonance.
So maybe that's generally only for resonance. This graph is not at resonance.
Resonance, yeah.
So then let me read the question. Which of the following graph represents the current versus frequency graph for a pure capacitor? So
Pure
obviously it
capacitor.
cannot be for resonance.
Resonance,
So my
correct.
assumption was wrong. I didn't read the question properly. The question is not at resonance. The
pure
question is not
capacitor.
at resonance. Purely capacitive circuit. You know, baby, XC is equal to 1 by
1
C
by C
omega.
omega.
Okay, so then current and XC are inversely proportional. So then I will be directly
Directly
proportional to
proportional.
omega. So it is a straight line graph. Such a beautiful question
Yes, ma'am.
where I misunderstood for a minute.
Yes, ma'am.
So let's go to next question. Is the ninth question. So this is the way to prepare for an exam. You have to take objective type questions like this and prepare all the MCQs. There's so many that's given in Aurora.
Yes, ma'am.
I don't know why students are asking me for question papers. You have Aurora with you. You
Yes,
have
ma'am.
all MCQs there. Try to explore your answers.
Yes, ma'am.
I am just exploring now.
Yes, ma'am.
This is the way you are supposed to explore.
Yes.
So ninth question. Show the This is a third level preparation. After you preparing the basic JEs, CBSE sums
Yes, ma'am.
and NCRT
NCERT
sums
sums.
and derivations.
Yes, ma'am.
Next preparation is this.
Okay.
You should take all the higher level
Yes.
sums into. So ninth question. Figure shows the variation of inductive reactance XL for two ideal inductors L1 and L2. They have given the graph XL versus omega graph. It will be linear. They have given
Yes,
it for two. This is L1 and this is
L2.
L2. The angle for this is 60 degree. The angle for this is 30 degree. So then, what is that? They are asking for with angular frequency. Find the ratio of L1 by L2.
L2.
You know L1 by L2. You know tan 30 is given.
Tan 30, yeah.
Tan 30 is opposite, which is what is in the opposite? XL.
XL.
What is the adjacent? Omega.
Omega.
You know XL itself is L omega by omega. XL itself is L. That is your L1.
L1.
Tan 60 is XL by omega, because opposite by adjacent.
Yeah.
And the opposite side is XL, adjacent side. So XL, this itself is L omega 2. Correct?
Yes.
By another omega 2, because the
Omega.
corresponding omega 1 and
Yes.
omega 2 value. So this is omega 2, omega 2 get cancelled. You get this, which is L2.
L2.
L2. You get L1 and L2, which is ratio of tan 30 by
Tan 30.
L1 by L2. Therefore, is ratio of tan 30 by tan 60. What is tan 30's value? Tan 30 is 1 by root 3. At tan 60 is root 3. So it's 1 by 3. So that's how you should write the answers.
Yes.
Let's go to next question. The next question is the 10th question. So what happens to the inductive reactance and the current in a purely inductive circuit if the frequency is half? If the frequency is going to be half, what happens to the inductive reactance? Inductive reactance is XL.
XL.
Initially it's L omega,
L omega.
which is L into 2 pi into mu. Now the frequency is going to be half. Then it will L is also, XL will also get halved only, no?
Yeah.
Correct? So it's just going to get halved. The inductive reactance will be doubled and the current will be halved. Okay, let's read the question once again.
Yes.
What happens to the inductive reactance and the current? So inductive reactance and current are
Current
inversely
inversely
proportional.
proportional.
If this is getting half, that's going
That
to be
is
doubled.
doubled,
So
yeah.
then you understand if frequency is getting half, the inductive reactance is going to be half,
Half.
and the current is
Current
going to be
is
doubled.
doubled.
That's the answer.
Yes, ma'am.
So next question, 11th question. What is the ratio of inductive and capacitive reactances in an AC circuit? The ratio of inductive reactance and a capacitive reactance is L omega by 1 by C omega. So omega square. It will become L into C into omega square. And that should be your answer. Straight direct question.
Yes, ma'am.
So let's go to 12th question. An RMS value of conduction current in a parallel plate capacitor. Take a parallel plate capacitor which is positive and a negative of 6.9 microamps. Oh, this is the RMS value of the current. IRMS is given
IRMS.
is 6.9 microamps. The capacity of the capacitor, if it is connected to a 230 volts, is connected to 230 volt AC supply, which means VRMS has been given 230 volts. With an angular frequency 600 radians per second. You can convert it to frequency if you want. It's 2 pi mu, so 2 pi into 2 pi into mu, and so what am I saying? Omega itself is 2 pi mu. So mu is equal to omega by 2 pi. If you want, you can do that. You can keep it omega as omega now.
Omega.
Why are they bringing in a capacitor? They want the capacitance of the capacitor. An RMS value of the conduction current in a parallel plate capacitor is 6.9 microfarad. The capacity of this capacitor, if it is connected to, which means isn't it like a purely capacitive circuit
yes,
connected to a 230 volts?
Yes, ma'am.
Can AC supply, correct?
Yes, ma'am.
And omega has been given,
Yes.
current IRMS is given,
IRMS.
ERMS is given. What they want? They want C. They want the value of the capacitance of the capacitor, right?
Yes, ma'am.
Yeah. So you know that IRMS is equal to ERMS by impedance Z.
Z.
Is it only capacitor? So it's only XC,
XC.
which itself is 1 by
1 by
C omega. Take it up. IRMS is equal to ERMS into C omega. IRMS is given to be 6.9 into 10 to the power minus 6. ERMS is given to be 230. And what is C? C itself you don't know. Omega you know is 600. Directly substitute and get the
Yes,
value of C.
Yes,
You should
ma'am.
interrelate this sum with a purely capacitor.
capacitor.
It won't strike you and you guys will leave it and come. Isn't it?
Yeah.
So then the 13th question is, I'll do one more MCQ and we'll stop with that. Okay, then they have given this capacitor like this and an AC source like this. They given an ammeter like this and they have given another resistor R like this. They have a voltmeter connected like this and they have another voltmeter here. Okay, then they're calling this as V1, they're calling this as V2. Okay, this is circuit. A given figure shows the capacitor and a resistor connected in series, which is like a CR circuit, which is omitted portion.
Okay.
A CR and LR circuit is anyways omitted.
Yeah.
But okay, now I want to. But a CR will be there. A CR will also be is CR circuit can behave like a filter circuit. Filter circuit where when an okay, that will come in semiconductors. I'll teach you later. So I've done some 11 MCQs for you. You must you don't have to do anything like a parallel because the series LCR only is there in
Yes,
portion.
ma'am.
Parallel LCR is not in portion.
Okay.
Like this you must explore and do it. Okay.
Yes, ma'am.